Good morning, everyone, and welcome to the October edition of the Southeast Monthly Climate Webinar, where we talk about the climate and special topics pertaining to the Southeast region. My name is Chris Furman. I'm the regional climatologist with NOAA's Southeast Regional Climate Center, and I'll be giving a climate overview of the past month. Our other speakers today are Jeff Dober from the Southeast River Forecast Center, who will provide a water resources update, Pam Knox from the University of Georgia, who will provide an agricultural impacts update, and joining us today, we have Dr. Chip Conrad, Director of the Southeast Regional Climate Center, who will be demonstrating one of our most popular tools, Climate Perspectives, which we use quite frequently on these webinars to help put recent weather and climate events into historical context. So thank you all for joining us this morning. Just a reminder to type your questions and comments into the question box at any time, and they'll be answered at the end. Also, a recap email of this webinar will be sent out with a YouTube link to this recording in the next day or so. All right, so let's jump into the climate. So looking at temperatures over the past month, boy, that map looks a lot different than it looked in recent webinars. We see a lot of green and a lot of blue and a lot of purple. That indicates generally below average, and in some cases well below average temperatures here over the last 30 days. And of course, many of you know we had an early season freeze in many places last week, and that certainly contributes to this. But even if we look several weeks prior to that, temperatures in general, as we sort of transitioned from kind of late September with Ian and into early October, temperatures in general were actually a few degrees below average across much of the region. So this, reflects not just what happened last week with that early season freeze in some cases, but also generally below average temperatures in the weeks prior to that. And you can see there on the right across Puerto Rico and the U.S. Virgin Islands, temperatures generally near average to maybe slightly above average. As far as the early season freeze, I'll just mention Pam is going to be talking about that a little bit more in her presentation. She'll be providing some climatological context for that, and Chip's also going to be talking about that as well in his Klimper demonstration later on. Okay, next slide. All right, looking at precipitation, really kind of two stories here. One is Hurricane Ian. So the locations that you see there on the left that are shaded in the blues, the purples, and the greens, which show above average precipitation. Ian contributed largely to that. Areas that that didn't see the effects of Ian, and also areas that just missed out on some of the precipitation that came with some of those frontal boundaries there over the last month. Those precipitation departures are much greater, and so you see areas there across Alabama, Georgia, parts of North Florida, even into parts of western North Carolina, where precipitation over the last month, in some cases, it's just half of normal, maybe 25% of normal, and even in some cases, maybe less than 5% of normal. So in terms of raw departures, these would be areas that are seeing anywhere from maybe 3 inches below average to as much as 4 or 5 inches below average during this period. And of course, that's contributing to emerging and developing drought that we'll talk about here in a second. As far as precipitation across Puerto Rico and the U.S. Virgin Islands, it was highly variable over the last 30 days. Some areas on the western side of the island seeing anywhere from 5 to maybe 10 inches above normal over this period, whereas areas to the east, like around San Juan, anywhere from about 1 to 3 inches below average. Okay, next slide. Okay, so let's talk about Hurricane Ian. So this has really been the big story, not just over the last several weeks, but really over the last several months, really. This has really been the big story here across the Southeast. You can see a loop here of Ian making landfall across the west coast of Florida. Actually made 2 landfalls there on the 28th of the month of September. And you can see it crossing the Florida Peninsula. It weakened and then reemerged across the Gulf Stream and then made a third landfall in South Carolina as a Category 1 storm, and had really big impacts, not just across Florida, but also across parts of the Carolinas and Virginia. So on the morning of September 28th, Ian intensified into a Category 4 hurricane with maximum sustained winds of 155 miles an hour, just shy of a Category 5 storm. And it came ashore near Cayo Costa Island in Florida around 3 o'clock in the afternoon. on the 28th with maximum sustained winds of around 150 miles an hour. That tied for the 5th strongest hurricane to strike the United States. And it's the strongest hurricane to hit Florida since Michael in 2018. It's also the first Category 4 hurricane to impact Southwest Florida since Hurricane Charlie back in 2004. So the real big impacts from Ian, of course, were water. Okay, not just in terms of precipitation. We saw anywhere from 10 to maybe 15 inches of rain over a very short period of time, in some cases less than 24 hours across parts of the Florida Peninsula. But we also saw, in some cases, record-breaking storm surge and high water marks. And this was certainly the case here in Lee County. So areas from Sanibel Island to Cape Coral to Fort Myers, even extending down towards Naples. Some of these areas had high water marks that have been recorded anywhere from 5 feet to 10 feet, and in some cases over 10 feet. And some of the highest water marks that have been recorded to date have been anywhere from 16 to 18 feet. Not sure if this is exactly a record-breaking storm for this part of Florida, but is certainly up there. As far as fatalities go, those numbers have been changing a good bit. Last count was in Florida, as many as or anywhere from about 105 to 129 fatalities, depending on which source you use. But in any event, it's the deadliest hurricane to strike Florida in over 100 years, or in about 100 years. Okay, next slide. Okay, looking at ENSO, so not much change since the last webinar as far as ENSO projections here for the season, for the winter season, and then into spring. We're looking at a 75% chance of La Nina over the next 3 to 4 months. So that takes us through the winter season here with a 54% chance of ENSO neutral developing by late winter and early spring. Okay, next slide. Okay, as far as the drought goes, so drought is reemerging a bit here in the southeast. So when we looked at precipitation on a previous slide, we saw that there's some real deficits across parts of Alabama, Georgia, and North Florida, and so that's reflected here in the drought monitor. And you can see also with the short-term drought indicator blend, which is driven largely by SPI values, you can see real deficits there. Particularly across parts of northern Georgia into northern South Carolina and also southwestern North Carolina as well. And that's where we've seen some of the biggest degradations as far as drought goes. Next slide. We'll zoom in here on the southeast specifically and look at how the drought monitor has changed from the last map we looked at in last month's webinar to the most recent map from last week. We were really talking about improvements last time. So we saw significant improvements across much of the region last month. But of course, since then, with the exception of Ian eliminating the abnormally dry conditions across Florida, as well as improving drought conditions across eastern North Carolina and Virginia, we've really seen not only the emergence of drought across parts of Alabama and Georgia, but we've seen really a rapid onset of at least a severe drought across parts of northeast Georgia. We also see some spot droughts around parts of northern, or I should say northwest Florida, as well as around Mobile Bay. And so when we ended the webinar last month, we saw about 80% of the region being free of any drought designation. Now, looking at the most recent map, we're about 55% drought-free, but we have about 43% of the region now in at least D0 conditions, and we have roughly 15% of the region experiencing either moderate drought or severe drought. Next slide. Okay, so NOAA released their winter outlook, as many of you know, last week, and it looks very La Nina-esque, right? So in terms of projected conditions for the winter across the southeast, warm and dry is the forecast for the next several months. Next slide. And as far as that, or as far as how that may impact the drought, we see areas where we currently have at least D1 drought. We see drought persisting in those areas. But we also see areas, again, especially across Alabama and Georgia and parts of North and Northeast Florida, where drought development is likely. And this takes us through the end of January. So it looks like, at least across the southwestern and southern tier, most of the southern tier of the region, it looks like drought will likely persist or potentially expand somewhat and develop here as we go into the next several months. Next slide. Okay, and that's just a summary here of what's happened over the last 3 months, so you all can peruse that when you're able, and I will turn the floor over to Jeff.
Alrighty, thank you, Chris. So here is our actually late autumn into early winter flood outlook and stream flow water resource outlook. And we'll start off, as we always do, with the 28-day average stream flow map. And you see, as Chris pointed out, we've seen some drought development across some portions of the southeast, and that's being reflected as well in the stream flows. This is typically a low stream flow time of year, this period in particular in mid-October. And so the stream flows are actually lower than our typical seasonal or yearly lows. So stream flow is pretty low right now. What we're also seeing is many of our reservoirs starting to fall, and many of them are falling because they're dropping to the winter pools. But overall, if we go to the next slide, breaking it down, actually, let's see, can we go back one slide? I think we skipped a couple. Looks like we're missing a couple slides here as far as the average stream flow. There we go. So yeah, overall, we're looking at stream flows across Alabama, Georgia, and then to Florida. For at least Alabama, Georgia, in the below normal range. And then for Florida, of course, with Hurricane Ian across most of the peninsula, we're running above normal. Then as we work eastward into the Carolinas, in South Carolina and North Carolina, we're treading that below normal to near normal level, as well as Virginia. Let's go back up 3 slides, and I'll show you where we're at as far as what I was talking about. Here's the 7-day average stream flow compared to the entire year, and you can see here our 7-day average stream flows are below what they typically would be, but for the entire year as well, which is not out of the ordinary. As you can see, the picture there to the right, August through October is usually our low stream flow period, really from the Mississippi Valley, Ohio Valley, all the way down into the southeast. The only exception to that, again, is Florida, where we're heading into the Florida wet, dry season, where they typically start to see low stream flows, their peak low stream flow period toward the early spring. And we'll slide, sorry about this, folks, but we'll slide a few slides ahead. And we'll show you the current conditions. And you can see most of the flooding we had around the Tampa area from Hurricane Ian has fallen out, which is a good thing. But we continue to have major flooding in the St. Johns River Basin at this time. And that will likely continue probably all the way into mid-November, mid to late November. Now, that doesn't mean that the flooding that we're seeing right now will continue into late November. What that means is that we'll have a gradual decrease in flooding impacts through that period. But even in mid to late November, we could still see some minor flood or nuisance impacts along the St. Johns River. Next slide. I'm talking about the impacts from Ian. As Chris was pointing out, that heavy rain area was pretty narrow from Fort Myers up through Daytona Beach. And it produced quite a bit of flooding, major flooding in these areas south of Tampa, all the way to the areas just east of Orlando. And many of these actually broke records. If we go to the next slide, around the Tampa area, So in particular, the Peace River here from Bartow, Florida, down to Arcadia, Florida, that's that area just north of Port Charlotte. We broke records from several years ago at Sulphur Springs. That record was set back in 1933. So all new record level stages at these locations that you see with dates. Moving over east into the St. Johns River Basin, this is even more pronounced as far as the flooding. If we go to the next slide, you can see many of the records held by some very prominent storms: Hurricane Hazel in '53, Dora in '64, and Faye in 2008. But we shattered all those records with Ian, and so Ian will hold the records for all these forecast sites along the St. Johns River. So quite a significant storm as far as water resource and flood impacts in Central Florida. Going to the next slide. And like we always talk about where we're at as far as river flood climatology, we're in week 43. And typically this is one of our quietest periods, if not the quietest time of year for the Southeast as far as flooding. Now, we go to the next slide here. And that's also true for our South and Central Florida river group, including the St. Johns and the rivers around Central Florida. You can see that pretty strong fall off there that we go from late September, early October to late October, falls off pretty considerably as far as the river flood events. And that pretty much fits what we're seeing right now, which with doesn't look like any pending threats as far as tropical weather next couple of weeks. So go to the next slide. That's our river flood climatology. And so overall for late autumn, early winter flood outlook and water resources, as Chris was pointed out, with La Niña type weather through this period and the potential for developing drought, we're looking for below normal risk of river flooding, below normal, the typical risk. Now, this doesn't mean that we won't have flooding. This just means that as far as the magnitude and the number of events, we look to be slightly less than what is typical. The only exception again is the Florida Peninsula, but they're also going into their dry season and low flood risk is typical. So basically we're expecting that a low risk of flooding for Central Florida as well, which is normal for this time of year. And that's all I had as far as the water resources and flood outlook. So in summary, we want to just quickly go through that. The 28-day USGS stream flows, again, nearer to below normal across the interior southeast. The exception, again, is the Florida Peninsula, where we're above normal. Typically, stream flows are at the lowest levels for this time of year, and we're seeing many of our reservoirs fall to the winter pool. And our 3-month period, we're talking about river flood risk to be below what is typical for the interior southeast. There'll still be some flooding, but less than what we typically expect as we head into our primary recharge period, late autumn and in the early winter. And as far as the Florida Peninsula, the dry season begins in late autumn. Flooding isn't typical during the wintertime season on the Florida Peninsula, and that's where we call for normal flood risk, which is seasonally low. And that's all I'll have. That's all I have, so I'll pass it on to Pam.
All right, well, thank you, Jeff, and good morning, everybody. Happy October. It's always an exciting time of year for farmers because they get to see what happened with their crops as far as the yield goes. So let's launch right in and just take a look at a couple things that Chris has not looked at yet. One is the soil temperature, which you can see across in the left graphic there is warmer than normal across most of the region because we've had all these days in a row of no rain and lots of sunshine, so things are doing well. Of course, we're not planting a lot this time of year. We are planting winter grains and some vegetables and forage, so those are worried. And there, really, the issue is more the soil moisture, which you can see from the right graph, a little fuzzy there. Sorry about that. Has been quite dry in most of the region. The wet conditions that show in North Carolina and Virginia are from the last system that came through If you looked at that same map today, I would imagine that that would probably have blurred out a little bit. So we're not doing a lot as far as planting goes, but conditions have been warmer and drier than normal, which is consistent with the drought that Chris mentioned. If we go on, just like to remind people that you can still do condition monitoring reports. This is the reports for the last 30 days. I have been getting calls from a lot of forage producers and livestock folks that are saying it's really dry and we're having to feed hay instead of being able to use our pastures. And so that again is reflected in that drought monitor and the increase in drought over time. So if you're seeing those conditions, or conversely, if you're seeing really wet conditions, as a few people are, it's always a good idea to put in a condition monitoring report and make sure that the drought monitor authors are aware of what's going on here on the ground, because they don't always get that information. So this is a great way to do that. If we go on, one of the things that Chris mentioned has been an interesting thing that happened in the last couple of weeks is the frost. The map on the left-hand side shows the lowest temperatures that it got to last week. And you can see, I wish they had a 32-degree line on here, but they don't. You can see that a lot of the region now has gone below 30 degrees, so definitely the end of the growing season for most of those areas. In the areas in blue, between 30 and 35 degrees. And so those at least probably saw some frost, if not a freeze. And so for most of those areas, effectively the end of the growing season for this year. Of course, Florida is the exception to that, at least the southern part of Florida, where they may not see frost at all during the winter or certainly much later. And the graph on the right, the map on the right, is from agroclimate.org, and it shows that 1 out of 10 years, the frost will occur before these dates. So if we look, for example, at the center part of Georgia, you can see 1 out of 10 years the frost will occur at or below the first week of November. So we're well ahead of that. And so the frost that we had was much earlier than normal, less than a 1 in 10 year event. And I think it did take some people by surprise. Looks like we probably won't see frost for a couple of weeks yet, but again, for a couple of weeks. But, for most people, that means really the end of the growing season for most. And if you didn't get a fall or winter crop established, then that's going to be of some concern to you. If we go on, the cold temperatures have also given us an early jump on chill hour accumulation. It's often started on October 1st. And you can see this is for Peach County, which is just a little bit south of Macon in central Georgia. They're well ahead of the historic average for this time of year. Of course, we're going to be warmer, so that'll tail off, and we'll probably get back below the long-term average here in the next week or so. And we're definitely way ahead of last year, which was in the dark green there. That is something that is of concern to fruit growers, because if we have a lot of chill hours early in the season, that means the plants will receive the chill hours they need to bloom in the spring. And then if we get a warm spell early in the spring, we could get early blossoms on a lot of the fruit trees and shrubs, which makes them more susceptible to frost damage if we get a late frost. So that's just something to keep in mind. We'll be watching this through the winter season. If we go on, some of the impacts of the recent conditions on agriculture. I'll get to Hurricane Ian in just a minute. But most of the crops are at the end of the growing season. Harvest is pretty much widespread. It was helped by the mid-October rain that we did have. It's been pretty dry, but we did have some rain. That helped soften up the soils for the peanuts. Otherwise, if the ground's really dry, the peanuts get stuck in the ground and it's hard to harvest them. They lose yield because of that. The dry conditions we've had, other than that rain, have made it hard to get small grains and winter forage established, and the result of that is that farmers are having to feed a lot of hay to their livestock. The frosted forage in those areas that did get down near freezing do develop some toxicity, and that can be problems for livestock. So that's another reason that livestock producers have to be very wary about forage that is available this time of year, just because you can have some toxic effects from the frost damage. It's also bad for some of the later planted soybeans, corn, and peanuts. Either they went into the ground late because of wet conditions in the spring, or they're a second crop that's planted after something else. So they have definitely been hurt this year by that early frost. The dry conditions, as I mentioned, have made it hard to harvest dryland peanuts, but that did improve with a rainfall in mid-October. And surprisingly, I mean, disease pressure is still there, even if the crops are not, even if it's not a row crop, we're still looking at other crops like blueberries where they're still feeling the effects of disease pressure, and they have to treat even in the season where they're not actually producing the berries, because you want those plants healthy going into the next growing season. So if we go on to the next slide, this is some of the impacts of Hurricane Ian on agriculture. IFAS did do a preliminary damage assessment of $787 million to $1.56 billion, but they haven't even gotten to some areas yet, and some damage may also be delayed. The picture on the left there of the, I think it's an orange, some kind of citrus, you can see the stem on that. The orange is still hanging on there, but the stem has just been shredded because that orange was twisting back and forth in the wind of Hurricane Ian. So that will probably be a loss as well, and it's hard to establish exactly how much loss that's going to be until they actually see the fruit drop. So those numbers could certainly change over time, but that's their initial guess. Over 5 million acres were affected in Florida. Just a tremendous amount went right through the main part of the citrus belt. So I would expect we'll see some price increases with citrus this year, although I haven't been following the futures market yet. Because of the rain, some areas got huge amounts of rain, up to 16 inches, I think, in some places, and some pastures and fields were underwater for weeks. Well, having that much water is not good because it really kills off the roots. And so obviously the pastures weren't growing, and some of the orchards also will probably experience delayed response to that flooding rain because it will have affected the roots and the health of those plants. Infrastructure was also affected, especially with things like workers' housing, and some barns for storage of crops and some livestock barns as well. Those are all things that are going to have to be rebuilt, and so there will be a lot of assessment about that. Some of those were insured, covered by insurance, but not all of them were, and so that'll be something that will be an ongoing thing. And based on other hurricanes we've had come through the southeast, that work may continue for several years before that's really all made right. And then not to forget the Carolinas, they did get hit by Ian as well. For the Carolinas, there was some wind and rain, but it's been so dry there that most of the rain was pretty beneficial. But the winds did cause some yield loss. I saw there's some pictures of wind damage just blowing the cotton off the plants. Once it's on the ground, it tends to get dirty, and it's much harder to harvest, although some of it could be probably harvested. And so there were some impacts there as well. I have not seen a numerical assessment yet of how much damage they've had. Certainly nothing like they had in Florida. If we go on, just over the next few weeks, looking ahead, it looks like the next likelihood of frost for most of the region is probably going to be around the first week of November. These are long-range forecasts. There's always some changes, and so you just have to watch that. But if you're concerned about frost, then you're going to want to keep an eye on that. Other than that, it looks like it's going to be fairly warm the next couple weeks, and so that will allow maybe a little bit more crop development for those late planted crops that are just a little short of being harvestable yet. Driest areas are likely to be in the Florida Peninsula and the wettest in the Appalachians. And there was, at least at the time I wrote this, an investigation in the Atlantic Ocean called Investigation 94. That's probably not going to come this direction. But if you watch the models, they do tend to put out some tropical storm activity. And so we're not out of the season yet. It's something we have to continue to watch, but we don't see anything on the near horizon for that. So if we go on, this is my summary. I'm just going to leave that there for you to look at later on the video if you need to, and turn it over to Chip Conrad.
All right, thank you very much, Pam. I have the privilege here of sharing the tool that we have on the Southeast Regional Climate Center website called Climate Perspectives. Next. And so this tool, and you see the web address there, basically assesses the ongoing and recent state of the climate across most weather stations in the Southeast United States. And in recent years, we've expanded this tool greatly across the remainder of the country, including Alaska and Hawaii. And basically, Climate Perspectives provides a fluid perspective on the magnitude of temperature and precipitation anomalies across different time periods. And it also finds the closest historical temperature analogs to recent weather and climate. And like a lot of our tools, it's powered by the Regional Climate Center's automated climate information system called ACIS. Next. Okay, and so obviously there's a tremendous amount of interest in sort of our changing climate and climate variability. And I think a lot of people, at least the lay public, really have misunderstandings around climate variability. And we see quite a bit of that. And over shorter time periods, climate variability can be much greater than long-term climate change. And so this tool is very effective in distinguishing this. And I show you here this map. This goes way back in February of 2015, and some of you may remember that it was an exceptionally cold month. And this shows, this is a product from Climate Perspectives. And you can see there, this is ranks of temperature from the 1st of February to the 28th of February 2015. And you see a lot of places are in the top 10 there. Then if you go off and you look towards the West Coast, you see a lot of places that had record warmth. And so that's just a classic sort of image there of climate variability and a very marked pattern where they had a persistent ridge over the West and a persistent trough over the eastern US. Next. Okay, so I'm going to go through here and just sort of give a demo on Climate Perspectives. Just to start off, and you can see the website here, there's 3 sort of areas that you can choose from, or 3 sections. And so I'm going to start off with Station Perspectives, which you can see up there sort of in the upper left. And then in the middle there is Regional Map Perspectives. And then on the right, we have Streaks and Thresholds Perspectives. So we'll start with Station Perspectives. Next slide. And so in Station Perspectives, the first thing you want to do is basically select your date. And because of the limitations, I couldn't encapsulate the whole, basically the whole screenshot here. But you have for stations, and a lot of the stations in the Southeast, you can choose for periods going back or dates going back over the last 2 to 3 months. And then we have something called Forecast Perspectives that goes forward to the next 5 days. And so basically, you first just select your date. Next. And then second, then you select your city, and then you just simply click Update Climate Perspectives. And so when you select your city there, there's a long list across the Southeast that you see there, but we have a lot of stations that are outside of these major cities. And so there's a box, and it's a little bit, you can't fully see it there in the screenshot, but basically there's a Google map. You can click a location and it'll tell you the nearest stations, or you can basically just key in the name of the town that you reside in, and then it'll show you the climate, basically weather stations in which we have a Climate Perspectives for. Next. Okay, so third then, so what you're presented then with is a table of values. And so it's very useful to compare these values across different time periods. Okay, and so next. And so I've basically blown this up. It's the same image, but I made it bigger so that you can readily see it. So I'm a little bit geographically biased here. So I pulled up Raleigh-Durham, the Raleigh-Durham Airport specifically, and I went back to last Wednesday, October 19th. And so I keyed in that information, and we get a Climate Perspectives for that particular date. So that's basically the first column there. And it also provides a perspective for the past 2 days. So that's basically the second row. Then you can see there following down the past week, the past 2 weeks, month to date, past 3 weeks, past month, season to date, past 2 months, and it can actually continues down going all the way to the last 2 years. And so the tool provides a perspective over a wide range of time periods. And so let's sort of dive into the details of this, just looking at last Wednesday. So at the RDU airport, you can see there, you can see under that column there, average high temperature, you see 60 degrees. That was the max temperature on that day. And so that was 12 degrees below normal. And you see that there. And then immediately underneath it, you see the ranking that it was tied for the 9th coldest. I believe this is a record that goes back over the last 76 or 77 years. That's pretty impressive. But what, of course, was most impressive was the low temperature. In the morning, it was 34 degrees. Okay, and so this was there was actually scattered frost in the area. So this was the morning that was coldest in the southeast. But anyway, you can see there that the temperature was nearly 15 degrees below normal, and it tied for being the 5th coldest for that date. Again, in a record going back well more than 70 years ago. So similar sort of thing for average mean temperature, and then you see there the total precipitation. We didn't get any precipitation. It's tied for the first driest, and I'll tell you in the record, most days, particularly this time of the year, there isn't any precipitation. So there's nothing too impressive about it being tied for being the first driest. What's really useful, and I think what people have really found to be effective in describing it, is identifying basically the best geographical analog for the temperature, for the max and the min. And so a high of 60 and a low of 34 is most analogous to the weather that's typically experienced in Billings, Montana. And so you see there in that last column, most similar city, Billings, Montana. If we go back the last 2 days, Billings, Montana also provides the best geographical analog there for those temperatures. And so if you kind of follow down through there, you see for the past week and the past 2 weeks, Oklahoma City is the best geographical analog, and so forth. And so you kind of keep going through there, and going all the way down to Oklahoma City, appearing again as we get down to season to date and basically the past 2 months. Next slide. Okay, and so one thing that we can do here is that we can basically click the View History button. And so if we just take, for that first day there, if we just basically click View History, and then we have little arrows. They're kind of hard to identify here. I can't use the mouse, but if we go down and we look basically at the ranked values there, you can rank the years for the average high temperature, the average low temperature, the average mean temperature. And what I did there was I ranked them from coldest to warmest for average low temperature. And so if you can see there, the coolest was in 2015, with the temperature was 32, and that was tied with 1948 at 32. And you kind of get the idea. And you see there on the red highlight there, basically 2022. So this past year, which the temperature was 34 degrees. So this is very useful in terms of finding years in the past that had very similar temperatures, or just more generally to see, well, it was pretty cold this morning. Well, how does that compare with past years, and what were those years? Next slide. Okay, and so I'm going to move on now to the middle tab, the regional map perspectives. Okay, and there's a number of variables to select for, but just first, when it pulls up here and you see these values, you can kind of see the variations in temperatures across the region. And I wanted to pull up the one that really perhaps stands out the most in the southeast, Tallahassee, where they got down to 33 degrees. And so you can basically mouse over any of these temperatures for these locations, and then basically a box will pop up there, and then you can hit view the latest climate perspective. And so I haven't done that here, but anyway, I highlight Tallahassee there, getting all the way down to 33. It was actually colder than the Raleigh-Durham Airport, way up in North Carolina, and that I think relates a bit to the different microclimates, plus the fact that Tallahassee managed to get more into the core, really the core of the coldest air. Okay, and so next slide. And so I'm just kind of highlighting here. So with the map perspectives, there's a number of selections that you can make there. So over in the left, you can see there, and I've really blown this up a whole lot, the variable that you select there. So I selected minimum temperature, but you can see kind of going over to the next column that you can choose between max temperature, min temperature, mean temperature, and total precipitation. Underneath that is the values, okay? And so you can see there, and choosing for the values, you can choose the average, which for most rows, is going to be, that could be the average for the last 2 days, the last week, or whatever. In this case, it's not exactly an average there. You can choose that, or you can choose threshold. So the number of days in which the temperature was greater than -10 degrees Fahrenheit, which for the Southeast is going to be a heck of a lot of days. But you can see there, you've got lots of selections, and I'm going to show you here in a few minutes towards the end of this presentation a little bit more about that. And then you select your date. And again, so you can go, at least for the major cities in the Southeast, you can select all the way up to 5 days in the future using National Weather Service forecasts. And then you've got a period going back, so days going back over the last several months there. And then after that, you select your period. So if I'm just interested in that particular day, I just select 1 day, the past 2 days, the past week. If I'm interested, in this case, in minimum temperature, season to date, or month to date, you can see there towards the bottom that you can select those out. And then lastly, the station display. Do you want to display the values? Do you want to display them as rankings or percentiles, or in terms of departures from normal? Next slide. Okay, and so here's an example here for the map perspectives in which I've selected out the ranks. And so it's just the same map as before, but now I've selected the ranks. And here you can see over many stations across the Southeast, they were ranked as the coolest there on record. Next slide. Okay, and so you can do this, of course, for precipitation as well. And it was an interesting year, as Chris and Pam were, or an interesting month, as Chris and Pam were pointing out, in terms of temperature variability. And these are colored here, and you can see the greens where basically the precipitation was really a bit somewhat above norm or on the high side. Then the areas that saw really little precipitation, so the stations there with the amounts that are basically highlighted there and basically there in the orange. And this, by the way, is for basically the past 2 months. Next slide. And so then you can select, we'll go in and select ranks. Well, how do these rank compare, as compared to prior years on the record for each station? And you can see the brown ones there. Those are stations in which the precipitation ranks were basically in the top 10 driest. Next slide. Okay, and so then the last one that we're going to look at here, and look at it very quickly because we're limited with time, is threshold perspectives. So the procedure is very similar to station perspectives in terms of what you populate there in the boxes. And we're doing the Raleigh-Durham, and we're doing October 19th there again. Next slide. And so we get this table here that basically shows the frequencies, and what I'm showing you here is in terms of temperatures that exceed various thresholds. So for these periods that you see there across the top, from month to date, past month, season to date, etc., going all the way back to the past year there, it just tells you the number of days in which the temperatures exceeded, the daily max temperatures exceeded those values. If you look down the very last row that's presented, and this actually goes all the way down to greater than and equal to like 105 or at least 110 degrees. But you see there, greater than or equal to 90 degrees if we go to the last 6 months. So that would be from basically April 20th to October 19th. We can see that at the Raleigh-Durham Airport, there were 81 days that were greater than or equal to 90 degrees. And that's 36.4 days above normal, which is really extraordinary. And that's reflected in the fact that the ranks is basically tied for the second greatest number of days in which the temperature was above, greater than or equal to 90 degrees. Next slide. And then we also have, lastly, what are called streak thresholds. And here is just, it identifies for the period of interest, the period that had the most consecutive days in which that threshold was exceeded. And so let's go down there where you see the box there that's highlighted, and I've sort of blown it up there on the right, but I think you can see it. You can actually see it there on your screen. So greater than or equal to 90 degrees, and going back to the past 2 months, we can see that at the Raleigh-Durham Airport, we had 12 days. This was between August 20th and October 19th, 12 days, and that's 7.6 days above normal. And so anyway, there was 12, and there were 12 days, 12 consecutive days. And so that was from August 24th to basically to September 4th. And so you can see there that that ranked, or that tied basically in as being the third warmest. And then if we look at the period of the past 3 months from basically July 20th to October 19th, we had 16 days, which is more than 8 degrees above normal. Again, this is consecutive days that equaled or exceeded that value. And so that period happened to be July 27th through August 11th. Okay, next slide. Okay, so I just want to thank you here. And so I've provided here 2 links. There's a particular link to climate perspectives in the Southeast, but we also have climate perspectives for the continental United States and also for other regions. And just real quickly, I wanted to acknowledge a few people. William Schmitz, our service climatology, he's provided a lot of input on this tool. July Yang, who is basically has been our IT person, she helped tremendously in the transition of our services from NC State. And I really want to acknowledge John McGuire and Ryan Boyles. Ryan Boyles at the time, as some of you know, was a state climatologist from North Carolina. So early stages of this project, he provided a lot of useful feedback. John McGuire did a lot of the programming. And also too, I haven't mentioned them, but Jordan McLeod, Sandra Rain, and Chris Furman as the regional climatologist for the center, they at different times have provided useful feedback in the refinement of this tool. So thank you very much.
That's wonderful. Thank you so much, Chip, for reviewing the Climper tool, Climate Perspectives. We do highlight that tool every single month in this webinar, and I think it provided some excellent background and context for how the audience can go back and explore data on their own. So incredibly useful. Good morning, everyone. My name is Meredith Muth. I work for the National Integrated Drought Information System as the Southeast Regional Coordinator for the Southeast Drought Early Warning System. And we co-host this webinar series along with the Southeast Regional Climate Center and the National Weather Service. Just a reminder to please include any questions or comments that you might have for the speakers regarding climate in the Southeast, something you heard today or something you're just curious about. Go ahead and enter that into the box and we'll get to it in just a moment. As a reminder, we will send out an email link either today or tomorrow with the webinar recording as well as key takeaways. There's a new website. You can actually share it extremely easily with your network and with your colleagues. Our next webinar is going to be on November 15th. Please note that this is 1 week earlier than usual. We're usually the 4th Tuesday of the month. We're doing this because of the Thanksgiving holiday week. We are really happy to have back with us someone from Climate Prediction Center to talk about ENSO as well as the winter outlook. There will be no webinar in December, so happy holidays. And then we have a couple of great presentations coming up. And lastly, after this webinar closes, a quick pop-up will come up asking for some feedback on how we can improve this webinar series that has now been going on for 3 years, including any topics that you would like us to talk about. And we would welcome suggested speakers as well. We cover a broad range of guest speakers and your ideas are really useful. So with that, I'm going to go ahead and start moving to the comments and the questions that we have. The first question is going to be for Jeff from the Southeast River Forecast Center. Jeff, what is causing the prolonged flooding in the St. John River watershed? Is the dam at Rodman Reservoir backing things up?
So thanks, Meredith, and thanks for that question. Doesn't have as much to do with that particular reservoir or any of the reservoirs on the St. John's. The St. John's actually, it's a little over 300 miles from north to south. It's a north flowing river. And over that 300 miles, the elevation change is actually about 27 feet. So that's about 1 inch of elevation change per mile going down the river. And so when you have a substantial amount of rain that we had in a watershed like the St. John's, it takes forever for that water to drain out. And that's really the true reason why these locations are staying in flood for the prolonged period that we're expecting, is that it's actually one of the slowest rivers in the world, actually. So not so much to do with reservoirs, more to do with the fact that it's just a very slow moving flat river.
It's great. Thank you very much, Jeff. The next question is for Pam. Pam, is there some preventive measures that citrus or other growers can take to preempt potential onset of phytophthora Diptera root rot from the prolonged wet soil. Hopefully I said that right.
I don't get all those names right either. I should just say I am not a citrus specialist, and so I'm sure that there probably are things that can be done, but you don't want advice from me because I don't have a green thumb. But I would suggest talking to your local extension agents or the local citrus growers association, and I'm sure that they probably got a lot more useful information than I've got. It's a big problem this year that really needs to be addressed.
That's great. Thank you, Pam. This next question is related to the Climate Perspectives tool, so I'll throw this one to Chip. Are there any connections or comparisons between the Climate Perspectives tool and the National Weather Service LCAT offerings? Maybe the former could provide a perspective for verifying the LCAT 3-month outlooks. This sounds like a little bit of insider speak for those who are working in the Weather Service, but perhaps you'd want to answer it.
Yeah, I'll just say, I mean, that's not something that we've undertaken. I think it would be really interesting to make that comparison. And I guess too, I'll just make a more general statement that we would love to get feedback on how we can improve climate perspectives and how we can think about it too as we're looking at forecasts. So currently we have the for major cities in the Southeast, we have what we call forecast perspectives, where we take the forecasted highs by the National Weather Service and we put those in a climate context. But it would be interesting to basically go out further in time and also just basically use it to evaluate, certainly to evaluate how accurate some of these tools are.
That's great, Chip. And I'll put that as a reminder in the email that we're soliciting information to improve this great tool. The next question, I'm going to pass over to Pam. This is an interesting one. So we get a really broad audience on these webinars. We have weather service forecasters and we have extension agents. And we also have someone from the Midwest who is asking, can you briefly define freeze hour?
Sure. Well, freeze hour is not something that I'm familiar with that term. So either it could be the number of hours below freezing, which is an important factor for some plants. If it just goes barely below freezing, then the plant could probably survive with maybe some surface damage. Another option might be that they're asking about chill hours, which I showed the graph of. A chill hour is the number of hours below a set threshold, usually 45 degrees Fahrenheit. And the number of hours below that threshold, whether it's 45 or 32 or whatever, is counted because that will tell you the likelihood that the plant is going to go through enough winter dormancy to be able to set a good crop of flowers and fruit in the next coming year. And so both of them are ways of counting the number of hours below a threshold. But the chill hours is the one that's really geared more towards fruit. And they actually use that a lot. I'm from Michigan, from the fruit belt in western Michigan, and definitely fruit producers there are watching the number of chill hours too. It's obviously a little bit higher when you're looking at the Midwest, and so they usually plant varieties that can take that cold weather better than we do down in Georgia.
Great, thank you, Pam. Okay, one more question and one comment. The question is, I'll make this one for Jeff, or start with you, regarding high water marks. Do you know when and where the high water marks for Ian will be made available?
Yeah, I do know they did go out and do some high water marks. I know the Melbourne office went out there. And that's something I'll have to look into and probably get back with the group on. I don't know those just offhand. I know that there is some data, high watermark data out there, but I'll have to follow up with you on that one.
Okay, that's great, Laura. We'll get back to you on that. Any other speakers can respond to when high watermarks will be made available? Okay, and then our last comment, this goes back to the question about flooding in Florida, and I'm going to open this up to the state climatologist from Florida, David Zierden. David, did you want to add a little additional context?
Yeah, I just wanted to comment on Lake Okeechobee and how it responded to Hurricane Ian. In late September, prior to the hurricane, Lake Okeechobee levels were very low for this time of year, around 12.5 feet. and it was a real concern going into the Florida dry season. But the Army Corps of Engineers manage the lake so that they leave a lot of buffer room to absorb rains from tropical systems in the heart of the tropical season. And it worked just as intended this year. Lake levels have risen over 3 feet since the passage of Hurricane Ian, but they were able to absorb all the floodwaters coming down the Kissimmee River. And so while the Army Corps of Engineers get a lot of heat for their management of the lake, this time it really worked just as intended. And now lake levels are in really good shape going into the dry season.
Oh, that's great context. Thank you, David. Yeah, it's been a really interesting month, and we'll see what the next month holds for us. Happy Halloween, everyone. And also, thank you again to our fantastic regular presenters, Chris, Jeff, Pam, and to Dr. Chip Conrad for joining us today. And with that, I wish you all a wonderful day, and we'll see you next month. Goodbye.